The expansion path and economic region of production are most important concept in the production analysis. In earlier lecture, we have discussed about the isocount, the concept of isocount, various properties of isocount. Now we are going to discuss about the expansion path and economic region of the production, which are the most important strategies for the increasing production level in the specific firm. The expansion path is nothing but it is a combination of various isocounts which indicated in the graph, which direct the several set of combination of the various inputs and certain output of the firm. With the help of this particular diagram, we are going to discuss about the concept of isocount, which was earlier discussed in the another session. This is the first isocount, which indicates 1000 quantity of production. This is the second isocount, which indicates 2000 quantity. This is the third isocount, which indicates 3000 quantity of production, and this is the fourth isocount, which indicates 4000 quantity of production. This is also known as a isocount map. If you draw the trend line between the different isocounts, we can get the expansion path. Suppose these are the various isocounts which are done based on the input and output of the particular firm, and this is the expansion path, which indicates the optimum combination of labor and capital for the production of certain quantity of production. Suppose you want to produce 100 quantity of production. This is the particular region, or this is the particular point where it is the optimum combination of capital and labor. If you want to increase the level of production up to 2000 quantity, this is the another isocount, but the optimal combination for this particular quantity is indicated through this particular point. Such a way we can identify the different optimum combinations of the labor and capital with the help of this particular isocount map and the expansion path. If you see, this is the one point, this is the second, third, fourth, and fifth. If you connect these particular points, we can get this particular line, which is known as a expansion path for particular business. This is the concept of expansion path for the production firm, which indicates the various levels of production and optimum combination of the various inputs, that is capital and labor. If you want to increase the level of production, we can go through this particular expansion path where the optimum combination of input will be indicated, and it is helpful to develop the planning strategy of the production. This is the expansion path. See, these are the points which can got through the particular cost lines and isocounts. Suppose there is the constant return of scale in case of production. How the expansion path will looks. Suppose there is a constant return to scale, it means there is a proportional rate of input and output. There is constant rate of return. In such a cases, the isocounts will be parallel to each other, and the distance between two isocounts will be same because there is the constant return to scale. If you want to increase the quantity of production from 1000 to 2000, you should move to this particular second isocount. If you want to move more further and want to produce 3000 quantity, you should go to third isocon. If you look, the difference between quantity of production and difference between these two isocons is same, because the constant return to scale. If you want to produce 4000 quantity, again the isocont will be shift forward, and the distance between these two isocons will be approximately same due to the constant return to scale. It means there is constant change in the isocont or shifting of the isocont. This is the expansion path in case of constant return to scale. Now we will discuss about the expansion path in increasing return to scale. It means there is an increasing return to scale in the production. If you add the 20% of the capital and labor, the production will be increased beyond that. It means the increasing return to scale. In case of increasing return to scale, the input and output ratio is greater. In such a cases, suppose you are going to produce 100 quantity and now you want to increase the quantity of production up to 2000. There should be little change in the isocon. If you want to produce 3000 quantity, the third isocont will be created, or it will be appears, but the distance between first and second is smaller than the earlier expansion path because of increasing return to scale. It means if you add small number of labors and capital, you can get more quantity of production due to the increasing return to scales. Hence, the space between isocontinuities is smaller or lower than the earlier expansion path. This is the expansion path in case of increasing return to scale. Third, expansion path in diminishing return to scale. It means there is more need of capital and labor for increase the production level. This case is known as a diminishing return to scale. It means the production level is diminishing with the increasing input. In such cases, the isocont will be shift more forward. It means the distance between the first isocont and second isocont will be higher than the earlier isocons. If you move forward from the 2000 quantity to 3000 quantity, again this isocont will be move forward and the distance will be greater than the earlier isocont. This is the example of diminishing return to scale and its expansion path. This is the expansion path in the diminishing return to scale. Now we will discuss about the economic region. These are the various isocons which indicates the quantity of production 1000 to 5000, and this is the expansion path which is earlier discussed in this particular session. This is the upper rigid line and this is the lower rigid line. We cannot move beyond this particular combinations because of availability of capital, availability of labor. In case of this particular isocon, this is the end point, upper point, and this is the lower point. We cannot move beyond this point in case of this isocon. Also, we cannot move from this point to this point due to the lower rigid line or restriction. Similarly, in case of second, third, fourth and fifth isocon, these are the lower bounds and these are the higher bounds. If you connect these bounds with the help of this particular curve or this particular line, it gives the upper right line and this is the lower rigid line. This is the economic region of the production where you can get the maximum production for your particular per. This is the use of expansion path for the determination of economic reason for the production. The economic reason of the production is the offshoot of the theory of production function with two variables. It is a cost-oriented theory which defines the region in which the optimal factor combination will lie. It serves a map of region of the optimal production. The economic region of the production shows the combination of factors at the certain costs that makes the economic sense. Areas outside the economic region of the production means that at least one of the input has negative marginal productivity. This is the part which is indicated in the dotted line. It is the outside of the economic region. Definitely we can produce in this particular point, but it is not a economic region. What is the economic region? Economic region is lies between E to A in case of this isocon. In case of second isocon, the F to B is the economic region. In case of third isocon, the G to C is the economic region, and in case of fourth isocon, the H to D is the economic region. If you connect these particular points with this curve, we can get the proper economic region for the production at different level of quantity or different level of production. This region is marked by the what are the called rigid lines, which are simply the boundaries beyond which one of the two factors is being overused. Therefore, outside of the economic region of production, there is the clear inefficient. It means if you go beyond this particular economic region, that production will be inefficient. Hence, this region is the efficient production region for the per. This is the implication or application of the expansion path, isopon, and the economic region of the production.